taking two linear equations. Linear meaning y equals mx plus b. We're going to take two linear equations, and those linear equations, y equals mx plus b, typically have two variables, right? Which two variables?
X and Y.
X and y. So, to solve a two-variable equation, you need two equations. To solve a three-variable equation, you need three equations. To solve a four-variable equation, you need four equations. Okay? So, and this is the whole deal with linear algebra. If you take linear algebra at another college, you'll learn things like matrices and stuff like that. And it's they're really not too bad. They're fun. They're simplistic. It's not hard once you get the hang of it. But for right now, I don't see a sense in going through the matrix, doing matrices and all that stuff. I think it's easier if we just look at two ways of solving the problem. One, substitution. Two, linear combination. Okay? So let's look at substitution as a primary method. Okay? And what I mean by substitution is, say you got one equation that y equals 3x minus 2, right? And then you get another equation of, say, I don't know, x equals 5. So now, you know these two equations, right? I can graph them, correct?
Absolutely.
I can graph them as the y and the x. And remember, the face, okay? And we have negative, positive, no solution, 0. So, no slope, 0 slope. When you have no slope, x equals a number. When you have 0 slope, y equals a number. Okay? So a nice face to remember. So now I have x equals a number, so I know that if x equals a number, it's the nose ring, which means it looks like a nose. So I know this thing's going to be straight up and down at 5. So 1, 2, 3, 4, 5. And there's my line. Not hard. Okay? So this is all chapter 7 stuff. Okay, that's why I'm going a little fast with it. Okay? Then I've got this equation. And I know that B is my y-intercept, right? So I'm going to do this in black. I know this is B is my y-intercept, so that's right here. So B is right here, so we're going to come down, we're going to go to the y-intercept, which is negative 2. Make a dot there. And then I'm going to do my slope, which is rise over run. And this is the one that confuses people because it's a 3 over 1. The rise over run. 3 over 1. So I've got a rise of 3, 1, 2, 3, and a run of 1. So this is my new equation. So great, I've graphed the two lines. So what is this? Well, this is what we call the point of intersection. It's where these two lines meet or cross. So the point of intersection's pretty important. How many places can two lines cross? One. Right. So well, it's actually wrong, but it's also half right. So two lines can cross at one place, right? Two lines can also cross at no places, right? And two lines can cross at infinite places if they are the same line but look different. Does that make sense?
Absolutely.
So you have three solutions. You have a 1 intersection. Okay, one solution. implies that they intersect. Okay? If they cross infinitely, infinite solutions, that implies that they are the same line. And if they cross not at all, or no solutions, what would that imply?
Inconsistent.
Good, but first we're going to stick with the words we know from last semester, which is, would they be parallel, perpendicular, parallel, because they never touch, right? So they'll be parallel. If they never touch, then they have to be parallel. Otherwise, they're going to touch somewhere, right? So they're either going to be the same line, or they're going to touch way down the line or right there in front of you. But if they're parallel, they'll never touch. Okay? Now we get to go with, are they inconsistent? Are they consistent? Or inconsistent, dependent, or consistent? So, I always get confused with these too, huh? So dependent means they are dependent on each other. Right? Dependent on each other. Consistent and inconsistent. Well, if they're inconsistent, someone said earlier, they don't touch, right? So what happens when they touch only once?
They're consistent.
They're consistent. So, if they touch all the time, they're dependent. So they're dependent on each other because they touch all the time. They're the same line. Okay? Does that make sense? Okay, so we got consistency, we got one solution, no solution, infinite solution. We know whether they're consistent, dependent, or inconsistent.